Okay, grade 9s, in today's lesson I'm going to go off on a tangent. And because our lesson is about tangents to a circle. So what is a tangent as we relate it to math? Well, it's this. It is a line that is going to touch a circle at exactly one spot. So this line, we could call it a tangent line because it's touching this circle at this one exact spot. This is not a tangent line, it's touching a circle at 0 spots. This is not a tangent line either, it's touching the circle at 1, 2 spots. Only this line right here is a tangent line. Also, the point where that tangent line hits the circle is called the point of tangency. So those are two things that you need to keep in mind. So, here's the biggest idea from 10.3 that you need to take away from this video. That if we have a tangent line and a point of tangency right here, a line coming from the center of the circle or a radius that touches that point of tangency meets it at 90 degrees. That is the biggest idea that you can take away with. It is that line right here, or it's that point right here. The third one says a chord drawn perpendicular to a tangent line. That just means that if we draw a line at 90 degrees from this point of tangency, it has to go through the center of a circle. That's what this third point is communicating to us. So we can use that to solve a variety of problems such as this show you know. So we have this radius CH that bisects this chord. The radius of the circle measures 10 centimeters. What is the length of CJ? Nope, that was the wrong question. Here's the right one. Line segment AF is tangent to the circle. Okay, great. At point E, line segment DF contains the diameter DB. Okay, great. And angle CEF is 34. What are the measures of these three angles? Explain your reasoning. So the first one we want to find is angle CEF. CEF. That's this one right there. Well, I know this one's 34, and I know that there's 180 degrees in a triangle, so how am I going to figure that out? Actually, knowing either of those two things doesn't really help me. What matters the most in this question is that we have a radius and a tangent line, and the radius is meeting this line at the point of tangency, so key idea number 2 means that this must be 90 degrees. Angle ECF. ECF, that's this one right here. Now I'm going to use my idea since I know two angles, and I know that the sum of all the interior angles in a triangle is 180 degrees. Now I'm going to go the 180 minus 90 is 90, minus 30 is 60, minus 4 is 56. This angle here has to be 56 degrees. Again, I found that out by going 180 minus 90 minus 34 equals 56. Okay, what is the measure of angle EDF? That is this little guy right here. To do this, I had to actually do an extra step. I had to figure out what this angle right here was first. And so by doing that, I went a straight line, has 180 degrees in it. 56 are taken up right there. So I went 180 minus 50 is 130, and then 130 minus 6 is 124. How does that help me? Well, I also recognized that I had a radius here and a radius here, which means I have something called an isosceles triangle. Anytime I have an isosceles triangle, I know that this angle here and this angle here must be the same. So then I went 180 minus 124, which is 56. And so the remaining 56 degrees in this triangle must be split evenly between those two angles. So I can find this out, this angle here, by going 56 divided by 2. 50 divided by 2 is 25, 6 divided by 2 is 3, so that's going to give me about a 28. So this one turns out to be 28 degrees. Might have to go back and re-watch that one. A lot happened there. We might also need to solve for some missing sides too. So in this diagram, PQ is tangent, K great, QR is the diameter. We have and a bunch of dimensions labeled already on this diagram. We got a 9 and a 41. What is the length of the diameter QR? Justify your answer. Well, when I go to justify my answer, I'm actually going to write down key idea I'm going to write down this key idea. A line that is tangent to the circle is perpendicular to the radius. So as I go to justify, I'm writing that statement down because that means I have a right angle right here. Which means I can use the Pythagorean theorem where I have a squared plus b squared equals c squared. My c is 41. A could be 9. And b, I don't know. Okay, so I'm going to 9 squared is 81. 41 squared is 1681. So b squared equals 1600. Square root both sides. B equals 40. So this diameter here is 40 millimeters. Number B. What is the length of chord QS? Well, this type of triangle with these little marks on it, this means that every single side is equal. That type of triangle is called an equilateral triangle. So if my diameter is 40, my radius has to be 20, and all of these three sides are the same. So that means this is going to be 20 millimeters. What is the length of chord RS? Justify your answer and express your answer to the nearest millimeter. Okay, so now I know that this length here is 40 and this one here is 20. Well, I have a diameter and I also have an inscribed angle right here. And so, standing on the same mark as the diameter, so now I have to use a key idea to justify from 10.1, and that idea is just that whenever I have a diameter and any inscribed angle that shares that same arc as the diameter has to be 90 degrees. So again, I can use a squared plus b squared equals c squared. And so my 90 degrees is right there. That means my hypotenuse is 40. This length here is 20. 20 squared is 400. The b squared, haven't solved yet, and then 1,600 is 40 squared. So I'm gonna go 1,600 minus 400, which is 1,200. So basically, I'm just going to do b equals the square root of 1,200, which turns out to be 34.6. So, your questions will involve solving for missing angles like we did in the previous example. So you might have to look for that tangent and radius and find that 90 degrees, and that will help you. Or you might have to solve for missing sides, in which you'll use the Pythagorean theorem, again, just like in our last topic. And so the goal will again be to look for a tangent and a radius. That will give you your 90 degrees so that you can hopefully identify a right angle triangle. Take care.